All right, so we're going to do 8.2 today, and I think the first half of the section is pretty straightforward. It's pretty easy. It's all graphing, and I do think that there's parts of this that are more difficult, but there's also an element of this that you guys may struggle with, but you really shouldn't because it's just plugging in values. So a lot of times with this graphing, it goes back to our old days where you plug in a bunch of x values and get y values. But the setup of the initial problem is where it can get tricky. The first part is pretty easy because there's not much you have to do, but it does get a little bit more difficult, and it is important moving forward that you know how to do this. So please pay attention, especially on the second page. I will try and go slow. If that means it has to be broken up into 2 videos, then that's what it means. We will see. So let's start with some vocabulary here. What we're doing is we're graphing simple rational functions here. So rational functions are something a little bit different than what we're used to. It doesn't mean that it's that much different. It just is a little bit new. So what we have here is a rational function has the form f of x equals p of x over q of x. In other words, what a rational function is it's a function over a function. And that's not, it's not entirely new from what we've been doing, but what you're going to start to see is you're going to see actual functions like, a function with an x in it on top and a function with an x in it on the bottom. Okay, so they're both polynomials. Okay, and q of x does not equal 0. Why? Because the bottom of a fraction cannot equal 0. The next 2 vocabulary are things that you're familiar with. The domain is the possible input values of a function, also known as the possible x values. And the range is the possible output values of a function, also known as the y values. So just getting right into it, what we're going to do is we're going to start with the parent function. So a parent function for rational functions is kind of like the inverse variation, what we did yesterday, and that's f of x equals a over x, where a is just a number. Okay, so even though it's just a number, it doesn't mean that it's not a polynomial. A polynomial can just be a number. It's just that the more complicated ones are, we're going to have variables on top and we're going to have variables on the bottom. But we're going to start with the basic parent function for these rational functions. So what we have here is, what you see in this example right here is 1 over x. Okay, here are the things that you have to know about the parent function. It is absolutely essential. First of all, we're talking about asymptotes. Now, we've talked a little bit about asymptotes, but not in great detail. An asymptote is a line, an imaginary line on a graph where your graph will approach it, but it will never touch it. So the parent function here has asymptotes. It's x equals 0, which is this line right here. It's the y-axis. And usually we represent these with dotted lines. I'm just going to show you on this one, and I'll do dotted lines the rest of the time. Okay, so here is our horizontal asymptote. That is our x-axis. So you notice your graphs, what they're doing is they're approaching both of our asymptotes. In this graph that we get, it's what we call a hyperbola. Okay, and a hyperbola it consists of 2 symmetrical parts called branches. So we have a piece that's right here, and what you see it happens is the graph is approaching the asymptote here as it goes to the left, and it's approaching the asymptote here as it goes down. And the same thing is up here. It's approaching the asymptote, the vertical asymptote as it goes up here, and then as it goes to the right, it's approaching this asymptote. It never crosses. Okay, rare occasions will it cross, but we're not going to get into that today. Okay, so let's do something real simple. Let's just talk about a basic function. We have y equals 4 over x. How do we graph this? Well, your first step is to always figure out what your asymptotes are. Well, if it's 4 over x, it's not any different than what we have here. The asymptotes will stay the same. Anything that is a number over x, the asymptotes will always be the axes. Okay, so therefore, what we have here is we have a function here that's y equals 4 over x. Therefore, our x equals 0. Okay, x equals 0 is going to be our vertical asymptote. Okay, so what I'm going to do is I'm going to plot that. And I'm going to change this to a dotted line. Okay, so there's my vertical asymptote. And then we have Our y is going to be 0. That's going to be our horizontal asymptote. Okay, and then I'm going to plot that, which is going to be right here. That's our horizontal asymptote. Okay, so that is the start of every graph when we're graphing rational functions, is doing your asymptotes. Now, here's where it gets easy, in my opinion. But I think that some of you guys will make this harder than what it needs to be. So what we're going to do is we're just going to simply plot points. These x values are just values that are to the left of the vertical asymptote and to the right of the vertical asymptote. So since our asymptote, our vertical, was x equals 0, I'm just going to pick 2 points to the left of 0 and then 2 points to the right of 0. So we have -2, and all we're doing is we're just plugging this into our equation. So -2, you plug into that, is 4 divided by -2 is -2. Gotta fix this. Okay, so we have -2 comma -2. We have -1 comma -4. And what we'll do is I'm going to plot these one at a time. So we have -2, so 1, 2 to the negative, 1, 2 to the negative. So there's 1 point. Actually, I want to do this in a different color, so that way it doesn't interfere with the asymptotes. Okay, so -2, -2. We have -1, -4. And then really, it doesn't have to be perfect, but the point is you know that your graph is approaching your asymptotes. So that's what an asymptote is. It's what the graph approaches. So you should get the general shape of your graph once you have your 2 points. You technically, but we're not going to do it this way, you could probably even draw your graph with 1 point, because we know where the graph's going to end. It's going to approach here, and it's going to approach here. Okay, our other 2 points. Plug in 1, we get a +4. Plug in 2, we get a +2. So we have 1, comma 4. And we have 2, comma 2. And again, we're going to do the exact same thing. It approaches the asymptotes, both of them. And we have another hyperbola, and this is exactly what it looks like. Okay, so what I want you guys to do is we have an on your own up here. I want you to try that one on your own after looking at this example. Again, what you want to do is make sure that you're plotting or showing what your points are. Don't just plot points, actually show what the coordinates are. Okay, so hit play when you're ready. Okay, so hopefully your graph looks something like this. Again, what you needed to make sure you did was the first part was drawing your asymptotes. Okay, so your asymptotes, because this function hasn't changed, it's just a 3 on top. We have x equals 0 is our vertical asymptote. We have y equals 0 is our horizontal asymptote. And then, again, all we did was plug in numbers. I plugged in -1, -2, and then 1 and 2, got my y values, plotted them on the graph, and then just drew my graph. And again, make sure your graph is approaching the asymptotes. Okay, so that is a simple rational function. That's like our parent function. Now, what we're going to do is we're going to talk about translating our rational functions. So, translating it, and this is exactly the same as it was before, but we're going to do it a little bit differently this time. So, there is one way we could do this, and that is we could graph our parent function, and then we could just shift it left and right and up and down. But we're going to continue to plot points because I think that'll be easier just moving forward. But again, the idea of this is the same. This h and this k are going to be very important. And the reason why this h and the k are going to be important is because the h and the k are going to represent what our new asymptotes are. So now our asymptotes are going to change. So if you recall, the h, we always moved the h in the opposite direction horizontally. So like if you saw, x plus 3, that meant that you were moving to the left 3 instead of to the right 3. And if you had, just like a plus 5 at the end, that was our vertical, so that would go up 5. So that just moves accordingly. Okay? So that's going to be the same thing that's true about our asymptote. If you see x plus 3 on the bottom, that means that our horizontal asymptote is going to move from x equals our vertical asymptote is going to move from x equals 3 to x equals 0 to x equals -3. So we're shifting it in the direction that we need to. So before it's just x, now because it's plus 3, it would move to the left 3. Okay, if it was -5, it would move to the right 5. Okay, so we need to make sure that we are moving our asymptotes accordingly. Okay, so the x value is going to change your vertical asymptote, and then this part is going to change your horizontal asymptote. So let's look at an example on the next page. So we have -6 over x plus 3 plus 2. So again, we're not going to worry about our parent function here. What we're going to do is we're first going to identify our asymptote. So if you think about your parent function here, it's y equals -6 over x. So what we've changed is we've put in this plus 3 here. This is where the opposite happens, okay? It means that our graph would shift to the left 3. Because that plus 3, it means that this graph, which it normally has a vertical asymptote of x equals 0, is going to shift to the left 3. So our new vertical asymptote is going to be x equals -3. And then our y asymptote, that's going to be what this plus 2 does. It was originally 0. Now it's changing to a positive 2. So that means we have y equals 2. So our first goal here is to draw these. And again, I'm going to draw them in red so you can see them. So x equals -3. 1, 2, 3. That's our vertical asymptote. Okay, we have y equals 2. Oh, sorry, do not, yeah, I apologize. These are by 2's, so we have to make sure we do this correctly. Okay, so the -3 will actually be right here, in between here. Get it as close as you can, no big deal. And then y equals 2 is right here. Always got to check the scale on the graph. Okay, so those are our asymptotes. Now what we're going to do is we're going to go through and do the same thing we did before. Because x equals -3 is our asymptote, we're going to pick two values to the left of -3. It does not matter what you pick. The reason why these numbers are picked is because we end up getting better numbers. We get whole numbers using those instead of fractions. But it doesn't matter. You can do a fraction into a decimal and plot it accordingly. It doesn't really matter. Okay, so we're going to do that. So we're plugging -6 in. When I plugged in -6 to save time, I got 4. When I plugged in -4, I got 8. So again, I plot those 2 points on the graph. So we go 2, 4, -6, and then +4, 2, 4. So our point right here is at 2, 4. Then we go -2, -4, and then 2, 4, 6, 8. There's our new point. And again, we're just going to draw our graph so it approaches our asymptotes but doesn't cross them. Do our other values, we have -2, -4, and we have 0, 0. So again, -2, -4 is right here. And then we have 0, 0, of course, is right here. And then again, we draw what we call our branch, but again, it's just our graph that's, we're going to have two pieces of our graph. That's a hyperbola, and you can see they're always a mirror image of each other. Okay? Now, the last part is the domain. Domain of these should be very, very easy because it will always be all real numbers except for the asymptote. And remember, domain is x values. We know the asymptote is x equals -3, so we can say that the domain is all real numbers where, and we don't have to say where, all real numbers, and you can just say x is not equal to -3, which means our range is going to be all real numbers and y will not be equal to 2. Okay? All right, so what I'm going to do is go ahead and hit pause and do this one on your own. And then when you hit play, you will see that this is going to be done for you, and I'll quickly go through it, and then we're going to have to get to a new video for the last example. Hit play when you're ready. Okay, so again, hopefully this graph is kind of what yours looks like without all the pretty colors. But here's the deal. Make sure that you have your asymptotes right. So your vertical asymptote should be at x equals 2. And we did that because it was -2, so we shifted the asymptote to the right 2. We shifted the horizontal asymptote up 1, so that is at y equals 1. These values do not need to be the same. If you did not pick the same x values, that's okay, as long as your graph looks something like this. The most important thing here is not about what the graph looks like, but that the asymptotes are good. Okay, all right, so go to the part 2 video to do the rest.